9.3 is more Pythagorean theorem, but it's with radicals, so it is slightly different of things that you need to see. So we're writing in simplest radical form. Okay, in this problem, I have one of the legs. I'm missing the other leg, so it would look something like x squared plus 3 squared equals square root of 58 squared. And that's how I write it. So I know 3 squared is 9. Square root of 58 squared is not as intimidating as it looks. Let's think about if I had square root of 10 squared. Think about what that would equal. Well, 10 squared is 100. If I square root of 100, that's back to just a normal 10. So really a square root cancels with a square. They're opposites of each other. They undo each other. So really this square and this square root are going to cancel, and I get just regular 58. Then I subtract 9. And that would be 49, which is nice because then when I square root, I simply get 7. Okay, number 2. I do have the 2 legs, so it looks something like 2 squared plus 2 square roots of 3. That whole quantity amount squared equals x squared. 2 squared is 4. Now when I do this, what I want you to think about is it's this time itself. So it's a 2 times the square root of 3 times a 2 times the square root of 3. Well, 2 times 2 is going to be 4. Square root of 3 times square root of 3 is really square root of 3 times 3 is 9. Square root of 9 is a 3. So it's really 4 times 3, which is 12. So in your head, you're thinking I'm squaring the 2, which is a 4. I'm squaring a square root, which they cancel each other out, and I just get a 3. And 4 times 3 is 12. And then 4 plus 12 is 16, which again is nice because then I get x to be 4. All right, number 3. 4 squared plus x squared equals 6 squared. 6 squared is 36. 4 squared is 16. Subtract 16. That gets a difference of 20, and I'm trying to square root 20. I do not want a decimal, I want a radical. Is this simplified? No, because 20 can divide by the perfect square of 4. So I'm going to break 20 up into a radical 4 times a radical 5. Square root of 4 is a 2. So x is really going to equal 2 square roots of 5. Again, not changing the value between the two answers, just rearranging it so I can make it look nicer. All right, number 4 is just written out in words. One of the legs of a right triangle, so I'm going to go ahead and draw one. However you want to draw, it's fine. One of the legs measures 2 centimeters and its hypotenuse measures 20. Find the measure of the other leg. If necessary, round to the nearest tenth. So now we're back to rounding. So I'm just going to go ahead and subtract 2 squared and not even do the squaring. 20 squared minus 2 squared is 396, and square root that. So I get 19.9. And this was given in centimeters, so I need to put a label on it. Okay, so beware, some of them are going to switch back to rounding the decimal instead of simplifying the radical.